So starting with the next exercise, or the very first exercise of chapter 5, that is 5.1, and the third question. So important questions we are solving here. So express the following in the form of a plus ib. Now students, what is this called as? This is called as complex numbers, correct? So complex numbers is generally denoted by a plus ib form. Okay, so what is given to us? I to the power of minus 39. This can be written as 1 by I to the power of 39, correct? So this 39 can be expressed in what again? So can we write it like this? 1 by I to the power of 3 whole to the power of 13, correct? 1 by I to the power of 3 whole to the power of 13, or this also can be written as what? I to the power of 39. So 1 by I to the power of 39 can also be written as 1 by I into 1 by I to the power of 38. So 38 means what? 19 twos is 38, correct? 19 twos will be equal to 38. So this again can be written as what? This again can be written as 1 by I as it is. So this can be written as 1 by I square whole to the power of 19. 19 twos is 38. 38 into I. This is into, students. 38 into I. So what is I square? So before we start here, so see here, I is equal to root of minus 1, correct? I square equals minus 1. I cube equals minus I, and I to the power of 4 equals plus 1. So you have to remember this, students. We have also seen this in the synopsis, correct? So the same thing you have to remember here. Now in the place of I square, what will you write? Minus 1, and minus 1 whole to the power of 19. So this is odd number, right? So we'll be getting minus only. So here we can write 1 by I into 1 by minus 1, correct? 1 by I into 1 by minus 1, because minus 1 whole to the power of 19 is minus 1 only. So this again can be written as what? Finally we can write this as minus 1 by I, correct? Minus 1 by I. So this minus will go up. 1 into 1 is 1, I into minus 1 is again minus I, so that minus will go up, into and divide by I, so we'll be getting minus I by I square, which is equal to minus I by minus 1, minus minus cancel. So here we can write it, we should express in this form, right? A plus IB, so we can write 0 plus I. So this is nothing but equal to how much? I to the power of minus 39. So this is the solution for the very first problem. Same thing, students, see I cube is equal to minus I. So minus I to the power of 30 is becoming minus I to the power of 13. So this is, we cannot get the right answer. So what we did, we wrote it in this way, I into I to the power of 38, and 38 again is written as I square to the power of 19. I square is minus 1. Minus 1 to the power of 19. 19 is an odd number, so it will become minus, and the remaining operations are as it is. So this is question number 3. Moving on to the next one. So again we have to express this in the form of a plus ib. So now what we'll do, distribute this minus sign inside. So what will be getting here? Here we'll be getting 1 by 5 plus I2 by 5 minus, you keep it inside, it will become minus 4, and again it will become minus I5 by 2, correct? So bring the numbers to one side and imaginary part on the other side. So that will become equal to 1 by 5 minus 4, okay? So here we will take I common, plus I we will take common. What will remain inside? 2 by 5 minus 5 by 2. This is what will remain inside. So 1 by 5 minus 4, take LCM, solve this. What will we get? We will be getting 1 minus 20 divided by 5 plus I as it is. Take the LCM here. 4 minus 25 divided by 10. Correct? 2 2s are 4, 5 5s are 25, 5 2s is nothing but equal to 10. So 1 minus 20 is nothing but minus 19 by 5 plus I of 4 minus 21. So that is 4 minus 25. So it will become minus 21 by 10. Which form should we express this in? We have to express in the form of a plus ib. So this again can be written as minus 19 by 5 minus 21 by 10 I. So this will be your right answer. So just check it once. 1 by 5, I 2 by 5 as it is, minus 4 minus I 5 by 2. Take the numbers on one side, 1 by 5 minus 4, and I we have taken out common, 2 by 5 minus 5 by 2. LCM 425 by, these both multiplication is 10, 4 minus 25 is minus 21 by 10. and this is minus 19 by 5, and the remaining things are as follows. Moving on to the next question. 1 minus I whole to the power of 4, this again can be written as 1 minus I whole to the power of 2 into 1 minus I whole to the power of 2. A minus b the whole square, a square plus b square minus 2ab into a square plus b square minus 2ab. I square is nothing but equal to how much? Minus 1. So 1 minus 1 minus 2i into 1 minus 1 minus 2i. Plus 1 minus 1 cancelled, plus 1 minus 1 cancelled, we have minus 2i into minus 2i, which is equal to 4i square. So I square is again equal to how much? Minus 1. So this will be minus 4. So how do we write it in the a plus ib form? So that can be written as minus 4 plus 0i. This is a plus ib form of question number 8. So what we did here, 1 minus I whole to the power of 4, we do not know the expansion. So this is written as product of 1 minus I the whole square into 1 minus I the whole square. Then again what we have used here, a minus b the whole square, that we have used and simplified and finally got in the form of a plus ib. Moving on to the next one. So do we know this expansion to the power of 3? We know that, right? So what is to the power of 3? So first of all what we'll do here is we'll take minus outside. So that will become 2 plus 1 by 3i whole to the power of 3. Now this is in the form of a plus b the whole cube. A plus b the whole cube is equal to a cube plus b cube plus 3ab of a plus b. So this is the expansion of a plus b the whole cube. Expand that in the similar manner, what will be getting? A cube minus will write outside. A cube is nothing but 8, correct? Plus b cube, that is nothing but 1 by b cube, right? A cube plus b cube. So 3 cube is nothing but 27. 1 by 27 into I cube, a cube plus b cube plus 3ab plus 3 times of 2 into 1 by 3 into I of a plus b. So that is nothing but 2 plus 1 by 3 I. Close the bracket again. So next step what will happen here, minus 8, sorry, so this 8 should come inside here, minus of 8 plus 1 by 27. I cube is nothing but how much, students? See here, I cube is nothing but minus I, right? So right there, minus I plus 3 and 3 got cancelled, right? What is remaining here? 2i, take this inside. 2i into 2, that will become 4i, and 2i plus 1 by 3i, so that will become plus 2 by 3i square. Moving on further, what will happen? This plus into minus will become minus, correct? So minus as it is outside, 8 minus 1 by 27 I plus 4 I square is nothing but how much here? Minus 1. So this is becoming minus 2 by 3. Okay. Now take the real numbers on one side and imaginary numbers on one side. What will happen? Then you have to simplify, that's all, finished. So here what will happen, which is equal to minus outside as it is. So this is nothing but 8 minus 2 by 3, 8 minus 2 by 3 plus I will take it outside. So we'll be getting minus 1 by 27 plus 4. Simplify this, minus as it is outside, 8 3s are 24 minus 2 by 3 plus I of 27 into 4. So 27 into 4, 7 4s are 28, 2 carried over, 108. So minus I plus 108 by 27. So a plus ib form we got, right? So which is nothing but equal to, minus we have taken outside, so the entire thing will be inside like this. Okay, like this. Okay, so further simplifying this, what will we get? 24 minus 2, 24 minus 2, minus sign as it is outside, 24 minus 2 is 22 by 3 plus I as it is. Inside what can we write? 108 minus 1, 107, 107 by 27. Close the bracket. So this is in the form of a plus ib, and this will be the right answer. So if you take the minus sign inside also, that is also fine. Or if you leave the answer like this is also fine. So that is just another step. So these are the 4 questions, or the first 4 important questions of exercise 5.1. Moving on to the next question. Starting with the next question, solution. So read the question first. Find the multiplicative inverse of root 5 plus 3i. So what is this? This is the complex number z, right? What is the multiplicative? So what is the inverse of this? The inverse of this is nothing but z inverse. So that is nothing but z equals 1 by z. So multiplicative inverse means what we have to do. So students, why is this multiplicative inverse? So z into 1 by z. Z and z will get cancelled, we'll be getting 1, right? So that is why 1 by z, that is nothing but z inverse is the multiplicative inverse of the given complex number z. So 1 by z is nothing but what, students? 1 by root 5 plus 3i. And as we know, and we have learned in the previous classes, like 9 and 10, root should not be in the denominator, right? So what we'll do here, we'll rationalize this root 5 minus 3i by root 5 minus 3i, which is equal to root 5 minus 3i by a plus b into a minus b. A square root 5 the whole square, a square minus b square. So minus 3i the whole square, which is equal to root 5 minus 3i by square and root will get cancelled, 5 minus 9i square. What is I square, students? I square is nothing but minus 1, correct? So this we'll write as it is, which is equal to root 5 minus 3i the whole divided by 5 minus 9 of minus 1, which is equal to root 5 by 5 minus into minus will become plus, 5 plus 9 is 14 minus 3i by 14. So this is nothing but the multiplicative inverse of the given complex number. Moving on to the next question. So again this we have to express in the form of a plus ib. So basic operations only. A plus b into a minus b is nothing but equal to a square minus b square, the whole divided by, so substitute this minus sign inside, what will we get? Root 3 plus root 2i minus root 3 plus I root 2. Plus root 3 minus root 3 will get cancelled. What is remaining now inside? So the square and root also will get cancelled. This and this also will get cancelled. So this will be getting 9 minus I square of 5 the whole divided by plus root 2 in plus root 2i plus root 2i, that is nothing but 2 times root 2 of I. So I square is nothing but how much? Minus 1, we know that. So in the next step what we'll be doing, we will rationalize, or we will try to eliminate this root. So that is nothing but 9 minus of minus 1 of 5 the whole divided by 2 root 2i into 2 root 2i by 2 root 2i, which is equal to 9 plus 5 the whole divided by 2 root 2 the whole square into 2 root 2i. So here also I have written I there. So next what can we do? This is 9 plus 5 into 2 root 2. This is 2 root 2, 2 root 2 the whole square. So next, simplifying this further, what will we get? 9 plus 5 is equal to 14 into 2 root 2i the whole divided by minus 8, correct? 2 square is 4, square and root will get cancelled, so 4 2s are 8. I square is nothing but minus 1, so minus 8 will be getting. So here again 2 7s are 2 7s are 2 4s are 2 1s are 2 2s are, which is equal to 7 root 2i by, so minus sign will go up again, minus 2. So what is the real part? So this is the imaginary part only, right? We have to express in the form of a plus ib. So therefore this can be written as 0 minus 7 root 2i by 2. So now we have expressed the given expression in the form of a plus ib. So this is the last question of this exercise. Moving on to the next exercise.